Hi, and welcome to Next Level Carpentry. There's no shortage of videos out there on YouTube about making flat panel cabinet doors. The videos show a wide range of methods for getting the flat panel or shaker cabinet door look and effect. So I wanted to put a video together to show how to make a flat panel door with solid wood construction throughout, from the frame to the panel itself, and use traditional tongue and groove joinery to hold it together. The process is pretty straightforward using standard shop equipment, and it ends up being a pretty long video because of the level of detail I go into showing how to fabricate and assemble these parts. It isn't intended to show you how fast I can build a pair of cabinet doors. I pack a lot of information into this video, so think of it more like master class with a carpenter rather than Saturday afternoon entertainment on HGTV. So let's go to work. The current project I'm working on is to build a small kitchen cabinet. Because it's an existing kitchen, we want the new cabinet and the new doors to match everything else in the kitchen so that it looks like it's always been there. The next part of the process is to make matching doors for the new cabinet so it looks like the rest of the kitchen. The whole kitchen is done in this knotty alder. It's solid wood. It's rustic knotty alder with some big knots and character marks in there. And I want to match that on the new doors so they blend in. Unlike a lot of flat panel doors, this particular design has solid wood panels because the character of the rustic alder isn't easily duplicated in a veneered panel. You can see this knot here runs right through to the back side of the panel. And the depth of the defects in the knots is deeper than the thickness of a veneer. Anyways, by having a solid wood panel rather than a veneered plywood panel, there's a few considerations for door design to make the cabinets beautiful and long-lasting. To make the solid wood flat panels stable and durable, they're designed with a raised panel on the back side of the door. That adds extra thickness to the panel, makes it more stable and less fragile. On a narrow door like this, that's not that big of a deal. The panel's only 4 inches wide, but some of the cabinet doors are almost 2 feet wide, and that wide, thin, real wood flat panel would be too fragile and unstable. The construction of this panel, with the raised panel being on the back of the door for stability, does a few things to the door construction to maximize the thickness of that panel, thereby making it more stable. The main thing that was done to maximize panel thickness was to offset the joinery in the door stiles and rails. In a lot of flat panel doors, this mortise and tenon joinery is centered up in the thickness of the door, but in this case, it's offset. So to match the new doors to the old, I'll just measure up the existing doors and make new parts to match. On this door, the stiles and rails are both 4 inches. The total height of the door is 30 inches. The existing door is 11 3/4. The new doors need to be 16 1/2. So the rails and the center panel will each need to be wider. I can see from faint sanding marks on the back side of the door and by the flatness of the back surface that these doors were run through a thickness sander during the original manufacturing process. And depending on how thick the passes were front and back, there can be some variance in the position of this joinery. Looks like a fat 3/4 or 25-30 seconds for a total thickness. The recess of the front of the panel is safe to say that that is 7/30 seconds, which will leave a 1/4 inch mortise and 5/16 on the back of the door. And because the raised panel is flush with the back of the door, the thickness of the raised panel is going to be 9/16 of an inch by combining those two numbers. The new door will be 16 1/2 inches wide, and taking the two 4-inch stiles off the 16 leaves me 8 1/2 inches for the width of the panel, and with a 1/2 inch tenon on each side, the panels need to be 9 inches wide, less a 1/16 of an inch for expansion and contraction. The height of these panels is 22 inches. With a 1/2 inch tenon on either side, the panels will end up being 9 1/2 by 23. I almost forgot that 1/2 inch. And with this information, I'm ready to start sizing the parts. Sizing the 4-inch wide stock for the stiles and rails is pretty routine millwork. Since the doors are over 3/4 of an inch thick, I'm starting with full 3/4 inch hit and miss lumber so that I can mill it flat and smooth so that I can end up at a thickness that matches the existing doors. The selection process is routine. The random width pieces I buy, I just look for the features that I want to end up in the final product and rip strips about 4 1/4 inches wide so they can be milled down to the exact width later. This stack of pieces will be the stiles and rails for the doors, and you can see that I mark on the end where the pieces will end up in the finished product. Because the flat panels, which are actually reversed raised panels, need to be only 9/16 of an inch thick when they're done, but a full 9 1/2 inches wide, I wanted to go a little more in depth to cover the steps I go through to end up with that size of a panel out of this rough stock. There's some complicating factors in producing those finished flat panels. Some of the things to take into consideration are the fact that these knots change from one surface of the board to the other. And I'm thinking that this crumbly knot is a little too much character for the look of the kitchen. So I need to know what I'll have left as I start to reduce the thickness of these boards. The 2 pieces I have here total 13 inches wide. I need to end up at 9 1/2. So I'll end up reducing the width of these panels by 3 1/2 inches as I go through the milling process. And also, like I said, the capacity of my joiner is 8 inches and the finished panel is 9 1/2, so I have to work around that limitation while going through the milling process. So with all that said, I'll start out with a few passes over to joiner to take off the bulk of this extra thickness and to see how the character marks change as the thickness is reduced. My goal in this process is to end up with a panel that's 10 inches wide and about 5/8 of an inch thick, but that is flat and true and has the character marks and the grain match that I'm looking for in the finished panel. Once all that's taken care of, the thickness planer has a capacity of 13 1/2 inches, so I can smooth up that panel as I dial it down to the finished 9/16 of an inch thickness. That sounds at least as complicated as it is, but I hope I can clear up any questions you have by the time I end up with the finished panels. When I'm at the hardwood store, I have in mind all the various pieces that I need for the finished cabinet doors, and I select pieces with an idea of where those pieces should end up in the finished cabinet. For example, there's a huge defect in here. That's getting a little carried away for the character in the cabinets. So I'm planning a couple of the rails to come out of these ends. This will end up in the wood box. Same thing with the pieces for the raised panel. This was one long plank. I cut it in half so that when I do the glue up joint, they'll end up near the center of that flat panel. All the wood is from the same board so that the joint will virtually disappear in the finished panel. Whenever I'm working with rough lumber, I like to give it a quick once over with some tools to remove any dirt or rocks that might be embedded in the surface. This stuff is pretty clean, but it is rough. Nevertheless, I'll use a sharp putty knife to sweep the surface. And anytime there's grit in the board, it'll make this sort of a noise. In this case, it's just a knot in the wood, but I confirm that. And this wood is clean. Sometimes the wood has been stored at the hardwood supplier for a long time and dust gets down into the wood. That's when I use a big square wire tug brush to scrub any of that fine grit out of the board, because it acts like fine sandpaper and dulls knives and joiners and planers and saws. I'm spoiled with this Powermatic joiner because it's such a beast of a machine, but I started out with a 4-inch joiner, advanced to a 6, and finally ended up with this 8-inch joiner, which serves the needs of this shop quite well. But even as nice as this is, it won't handle a 9 1/2 inch board, so I end up using the same workaround that I used on the 4-inch joiner and the 6-inch joiner. That's just good knowledge to have. I've decided which surfaces I want to remove the most material from, and I'll take a heavy pass to start thinning these down. And for a heavy pass, it's tough to beat a helical carbide cutter head and a 2-horsepower motor. I forgot to mention I left these boards long enough so that the two panels will be made end to end. I'll cut it in half after everything's all sized up. I like to optimize the size of pieces I'm running through the equipment, generally keeping them short enough to handle, but not so short that I have to deal with snipe on each end of each panel. With the first side flattened on the joiner, I'll flip these and clean up both faces on the thickness planer. Then I'll make a decision about joining the edges. With those joining and planing passes, I'm at just a skosh over 11/16 of an inch. These pieces both have 1/8 of an inch to go, but with the way the knots are revealed, I'm comfortable making a joining decision for the pieces. Because both of these pieces came from the same board, color matching shouldn't be too much of an issue. This setup here would make a beautiful match, but there's hardly enough character in the face, so I want to consider other options. This puts more character into the face, but the grain isn't going to be a very close match. I like that matchup, and there's a decent amount of character, but if I cut the panels in half, it's going to be more character in one door than the other. So I'm going to pull another trick here, and I like that setup there. So I'll joint these two edges for a match. I can mark the face with a triangle so that I end up back in this same orientation. And because I'm edge gluing panels, it's essential that the fence be dialed into exactly 90 degrees so the panel glues up flat. With the mating edges cleaned up on the joiner, I'm liking the look that'll end up on that panel. And now I need to remove some of the excess width so they end up with a 10-inch panel for gluing. It looks like I can remove that whole defect there without a problem by ripping this side to 4 3/8. And ripping the other side to, let's call it 5 3/4. I always keep in mind that I can cut them off, but I can't cut them on. So I leave a little extra thickness on there. The center joint is rocking a little bit, so I can take another whisker off of each of those faces to get a perfect glue joint. And that is a perfect fit for a glue joint. And I've seen on other videos and channels stuff about, well, if your fence is out of square, you can make sure you orient the pieces one way or the other so that the angles both offset the same way and your panel ends up flat. I just like the idea of squaring up the fence and not having to worry about it. So after those steps, I have the rough panel here. It's 10 inches wide, still going to trim a 1/2 inch off when this is done. The thickness is 11/16. I've got a 1/16 of an inch more I can take off of each face or all off of one, whatever makes the most sense. But the bottom line is this panel is ready to glue up so that it can be drying while I work on milling the other parts of the doors. From what I see in here, I think my gluing process is noticeably different from a lot of what's being taught. It works well for me. I've been doing things since developing this method 15 years ago or so. Never had a failed glue joint on a project. So just take what you see for what it's worth. I brought the panel over with the glue up mark and rely on my bench habit to secure the work. Yep, and you heard me right, it's a bench habit, because everybody knows that what were once vices are now habits. There's my bench habit. And for consistency, you'll see that I also have a swivel habit in the shop. With the board firmly clamped in place, I'll apply a liberal coat of Titebond 3 glue. Everybody's got their trusted favorite. Mine's Titebond 3. I want to make sure I got 100% coverage on that joint. More is better. Personally, I never worry about squeeze out because I have a couple ways of dealing with it. And in this case, because there's extra thickness, any squeeze out that's on the surface won't matter because it'll get planed off in the process. If this was the finished panel thickness, in a case where I needed to make an 18-inch wide panel that wouldn't fit through my thickness planer, I would still do things the same and not worry about the squeeze out. You'll see why. As the clamping pressure works out the glue, I'll dial up the pressure and maintain a flush surface in the process. Because it's a thin panel, I like to stagger the clamps from one side to the other. The bowing of the clamp as the pressure comes on can pull the panels, even if the edges are square, can pull the panels and fold them up like a taco shell. Your finger can detect just a few thousandths of an inch offset in the joint. Just work my way from one end of the panel to the other, and I can use the leverage at this end of the panel to steer the two pieces so that they're flush where the clamp is going to tighten up the joint. Because I had the luxury of extra width, I'm not worried about these clamps smashing into the edges of the panel because the edges will get jointed and trimmed off. Besides that, a 1/2 inch of the panel on either side is going to be hidden into the rabbets in the door stiles. Besides, so I'm covered all sorts of ways. The shop is cool, so this glue has plenty of working time. So I'm keeping after this steadily, but not anxiously. In general, clamps about every foot or so are enough. All the joints are still flush. I give everybody one final tweak, and that's that. I'm pleased with the amount of squeeze out all the way along. I like to see that. Once all the clamps are in place and the panel's stable, I can take it from the habit to the table. I've gone over it in other videos before. I don't like the idea of leaving this glue on here to set up and get hard and then chopping it off later. It just makes a mess. It's so easy at this point to soak up that excess glue with a couple handfuls of guy glitter. Sawdust connects to that glue, and a sharp putty knife wipes it right off. The only time this method's a problem, and it would be a problem with any method, is in a deep grained wood like oak or mahogany. The glue that runs out and streaks onto the wood can soak into those pores and they'll show up in the finish later. So if I'm working with a deep open grained wood and I'm not going to plane the entire surface clean, at this stage of the game I'll take a wire brush and rub down in to pull the glue out of the pores of the wood so that they don't spoil the finished product. Second verse, same as the first. A little bit of guy glitter and a putty knife. You can see all the glue is right there. That way I never end up with a starved glue joint or a failed. So that's good to go. Once it's set up for a couple hours, I'll run it through the thickness planer to take it down to its final thickness, size it to width, and cut it to length. And we'll have two reversible raised panels to work as those flat panels in the doors. Once the glued up panel has had enough time for the glue to properly set, I can unclamp it. Now that the panel's out of the clamps, I'll use a pair of winding sticks to show how flat and true this panel is before it goes through the thickness planer. The stick lays flat on the panel, showing that there's no cup or bow to the glue up. And then by eyeballing across the winding sticks, you can see that there's no twist in the panel. Any twist would show up with an unparalleled margin between the two sticks. Because I want a very smooth finish on this panel and it's such a wide piece, I'll switch the planer to the slow speed for bringing this down to 9/16 of an inch. One frog's hair over 9/16 of an inch, just where I want to be. A pass over the joiner and a couple passes through the table saw. I've got two flat panels, 23 by 9.5 by 9/16 inch thick. with good character on one face of each. When making door stiles and rails, I like to straighten one edge and rip the second edge on the table saw and leave the width a 1/16 of an inch proud of my final mark. That way I can run two 1/32 inch passes through on the thickness planer and eliminate that much sanding on the edges of these boards after the door is assembled. And for this door, that means starting at 4 1/32 for the first pass and right down to 4 for the second. And because the edges can sometimes be more susceptible to chipping, I run these two passes at the slow speed also. I like to stagger the ends of pieces when I'm feeding them into the planer because that minimizes snipe when the cutter head doesn't have to jump on top of all those pieces at the same time. I'm careful to line up the pieces snug together when they go into the planer. I don't want this tipped one way or the other, which would leave beveled edges on everything and ruin the pieces. And as long as the cuts are square, when I bunch them together and feed them in, everything comes out perfectly square and true after those two passes. Now that these pieces are sized, I'll use notes I made in the beginning to cut the stiles and rails to length. For cutting stiles and rails, I like to use the gang cutting method that I describe in length in another Next Level Carpentry video. I'll include a link to that video at the end of this one. I'll cut a couple extra rails to the precise size so I have some sample pieces for setting up the tenon. Once I've gang cut all the stiles and rails, I break apart the bundles and lay the pieces out the way they'll end up in the finished door so that I can match the grain and the rustic features of the wood. I first select the show face of each piece and then plan out the look that I'm hoping for on the finished doors. Those two will be the pattern pieces. I'm just positioning these parts so that the rustic features are somewhat evenly distributed between the two frames. I like what I got there, so I'm just going to letter these in random order here so that I can return to this orientation after the milling is done. The side with the letters are the face side, and I'll mark the approximate location of the dado in each of the pieces. And with all that planning taken care of, it's time to cut the dados in all these pieces. I'll start with a test pass on one of the spares. Another quick note here about the setup. Because I'll be milling my own hardwood panels, I can make the panel fit the slot. In a case where the flat panel is a piece of MDF or veneered plywood that's going to fit in there, those sheet goods are generally undersized by a 64th or a 32nd of an inch, so I need to make the slot fit the panel rather than, in this case, I'm making the panel fit the slot. Hope that makes sense. I'll mark the 1/2 inch depth of the dado on the face of one of the spare pieces and set the dado blade to that height or depth, as it were. I use the knob on the crank to lock in that depth. If anything, I'll set this the slightest bit shallow because I can always deepen it later. Next, I set the fence for 3/16 of an inch, snug it down. And for reference, the fence is always the face of the door part. I could set up a featherboard at this point, but because I've only got 8 parts to do and the pieces are true and flat, I'm confident that I can get a consistent result just with finger pressure against the fence. This fractional reading dial caliper tells me I'm a little thin on that dimension and a little thick on this one, so I'm going to move the fence over to adjust that for a better match to the original millwork. The depth is a little shallow also, so I'll deepen that at the same time. Take 2. I like the result of that adjustment, and I can go just a touch deeper, which I will. And I'd say that is good to go. Now that I'm happy with the dado setup for this joinery, I'll run all the parts through and then cut and fit the tenons. I'm careful to stage all the pieces before I run these dados so that the face is going to be against the fence and the edge that gets dadoed is on the table. So all I have to do is pick them up, run the dado, and then put them back. Everything ends up oriented properly when it's done. Beyond that, running this dado is routine. Now that the stiles and rails all have the dados in them, I'll add a few chippers to the dado blade so that it can cut the cheeks of those tenons in one pass. I used magnetic dado shims in the stack to get the dado exactly 1/4 inch wide. The tenons are a 1/2 inch deep or wide, whatever term you want to use, but I'll set up the dado blade to 5/8 and use a sacrificial fence so the dados can be cut in one quick pass. The sacrificial fence can be anything. I've just put a piece of Russian birch plywood on there. I can lower the blade and slide the fence over just a little ways and then run the blade up into the fence to the approximate depth of the deeper of the two tenon cheeks. Now that the fence is prepared, I'll bring the dado blade up to the height of the shallower of the two shoulders. Once I've raised the dado blade, I'll lock in the height setting. Next, I'll adjust the fence for a 1/2 inch tenon length. And I can't use the rip fence tape measure because of this auxiliary fence. And now I run the first test pass on a sample piece with the face on the table. And a close look at this tells me that blade's just a little bit too deep. So I back it off and run a second test. The difference will never show in the camera, but I like that better. I'd rather be just a touch thick than a touch thin at this point. Now I make sure these settings are locked in and run the first pass for all the tenons on all the parts. Because the tenon joinery is offset in the thickness of the door, I've got to make a second adjustment to the dado blade for the height on the other side of these tenons. And setting that blade height is like guessing a woman's age. Always guess low. After tweaking and dialing, I like the snugness of the fit. And there's bound to be a little variance of the fit from piece to piece. This is woodworking after all and not machining steel. So it's a case of aim for perfection and settle for the best you can do. Because I'll be using a router instead of a shaper to mill the profile on the back side of these flat panels, I'll pre-mill with a table saw to remove the bulk of the material. That way the router bit has less work to do when cutting this wide curved profile. The most important thing is to make sure that the tongue that fits into the dado and the door stiles and rails is the right thickness so that the panel fits snugly but not tightly. With a 1/2 inch of the tongue buried in that dado, it looks like the total width of that profile is 1 5/8 inches. Get a little bit of a brain cramp doing this because normally the raised panel side is the finished side. So I'll mark out the approximate flange thickness and profile width for reference when I make the cuts on the table saw. I trace the profile of the cut that will be made with the router bit onto a piece of thin cardboard, cut out the profile with scissors, and then lay the profile on the end of the panel and trace it out so I can use the curve of the router bit to guide the cuts on the table saw when I remove the bulk of the material. With the table saw blade set at 45 degrees, I eyeball the cut that the blade will make against the curve that the router bit will take later, and take conservative cuts to remove as much of that bulk material as I can. Once I've got this set up, I'll make that cut on all 4 sides of both back faces of both panels. This pre-milling process is quick and easy, so I actually made 3 separate passes with the blade set at 45 degrees to remove the bulk of the material in the curve before I switch the setup to cut out this chunk of wood in the corner. With a zero clearance insert in place and the blade set back to vertical, I set the fence to a fat 1/4 inch because I don't want the table saw blade to determine the thickness of the flange on the end of the panel. I'll do that with the router bit. With this setup, we'll cut away the bulk of the finished profile. This is the auxiliary fence setup I have. I don't do that much work with a router table setup, so this is plenty good. It just clamps onto my regular rip fence so that I can use it for setting profile depth on this kind of routing procedure. To get the full 1 5/8" profile, I'm actually overreaching the capacity of this router bit, so I'm using a router fence, and I've removed the bearings to get the maximum width of cut out of this bit. I'll make the cut in 2 passes by positioning the fence twice. As I do each edge of the panel, I check it in my pattern for a smooth fit. If it's tight, I'll run it another pass over the router with a little more pressure on the wood to get a better fit. And that'll be a nice even fit for those panels to allow them to float in the doors. After finishing the joinery on the doors and the milling on the panels, I'll sand the panels completely, and then on the door frames, I'll sand just the inside surfaces before gluing the doors together. Sanding of the surfaces and outside edges gets done after the glue up. And sanding is my unfavorite part of the process. So I make sure the final pass of all the milling is as smooth as it can get to minimize the sanding that's required afterwards. I want the panels to be held firmly while I'm sanding, and I'm able to drop the panel on these blocks and get good clamping pressure for sanding this curved profile. At this stage of the sanding process, my goal is to remove any burn marks, any saw marks, any router marks that are in the surface of that wood. I'll start out with 100 grit paper on a curved sanding block to smooth up the profile, and then I'll do the flat surfaces with a random orbit sander. A piece of sharp 100 grit sandpaper gets that accomplished quickly, and the scratch it leaves behind is easily removed with 150 or 180 grit sandpaper. This 5-inch Mercadero sander makes quick work of cleaning up mill marks out of these flat panels. Each of the stiles and rails gets a quick lick with 150 grit sandpaper on a stiff, hard block. Because these edges need to seal up when the door is put together, I'm very careful not to round this sharp corner in the slightest. But this sanding step breaks the mill glaze on the surface of the wood and helps the stain take evenly. I fold the sanding disc like a taco shell, take 1 pass inside the groove to shear off the wood fibers there, and repeat the process for all the parts. With all the sanding done, I'll make a final choice about which panel goes how and where in each door, and do a final dry fit before the glue up process. The difference here of a skinny 1/8 of an inch is the amount I allow for expansion and contraction of the door panel. With both of the new doors all dry fit, looking good, and remarkably like the original door, it's time to take them over to the bench and get them glued up. When I'm getting ready for a door glue up, I like to have all the supplies and tools I need all laid out so that I can work quickly and efficiently to get the best results with the least amount of stress. I have protective scrap blocks to tape on to the door stiles to protect the wood from the clamps. I have a bottle of fresh glue. I don't want something that's old and thick, so the glue joints go together quickly and smoothly. I have a silicone tray, silicone brush, and some water. I like to have a few scrap pieces of MDF that happen to be the same thickness as the panel. I put a 45-degree end on them so that they'll slide through this dado and clean out any excess glue that gets in there, and that keeps the panel from getting glued into those slots. I want the panel to float. I have a plastic hammer and a block of wood for adjusting the joinery during the assembly and clamping process, a sharp putty knife for cleaning off extra inevitable glue squeeze out, a couple of clamps naturally, and a paper towel for just cleaning things up during the process. My bench is set up for working quickly and efficiently, but it's a little less than ideal for shooting video, but that's the way it is. I clamp the door in the bench habit with the ends projecting so that I can easily get clamps on them. I keep the door with the show side out so that I can watch the joints on the face more closely. I tape a protector block on each side of both stiles ahead of time. I don't want to be doing that in the heat of battle. Then I disassemble the door and stage the pieces for quick assembly. and I'll run some glue into the plastic cup. With a brush that's damp but not wet, I'll paint the ends of the tenons and slide them together. I want to make sure all the surfaces are thoroughly covered, and especially make sure that this face of the joint has a good coat of glue so that the stiles glue up tightly to the rails. I also pre-prime the inner surfaces on the other side of the joint and fit this together. I'm making sure that this is perfectly flush on the end. Putty knife helps sop up extreme excess glue on these surfaces, and the MDF strip with a sharp point cleans the excess glue out of the panel slot. This alder is pretty porous, and I want to make sure that surfaces have a layer of glue on them, not just glue soaked into the wood. No need to cringe at the excess glue. Take special note that I'm not using a rag and hot water here. I'm cleaning this excess glue up mechanically with a sharp putty knife and this little tool. Once that's done, it's time to slide in the panel. And because the joinery is snug but not tight, I'm able to center that panel so that half of the space is on this side and the other half of that expansion space is down in the dado. Working quickly, I butter up the other sides and going by and giving this thing a second coat if that soft wood soaks up all the glue. And here I want to make sure there's good glue coverage on these two outside shoulders where the tenon joint comes together, and I'll scoop out this dado joint so that the glue doesn't bind the panel. That all looks copacetic. So I bring this together. And this is where the plastic hammer helps line up all the joints. If I need to bring a stile or rail out, I can use the block to get the same thing done. The goal is to get everything nice and flush before the glue sets and the clamps are applied. I still like the way all the joints line up. With these particular doors, as long as the ends of the rails are square, the clamping pressure will square up the door. If these are narrower, or if any of the joinery is a little loose, it's more critical to check the squareness of the door after the glue up. I want to make sure there's no wet glue in these tight corners, so I use the corner of a wide putty knife to get that cleaned up. Once I've got the initial clamping done, I can set the door flat on the bench, use a little bit of guy glitter, and then use my sharp putty knife like a cabinet scraper to even up any small differences in the faces of these pieces and remove excess glue. The slight scratch marks left by the putty knife are easily sanded out. This is a little late in the game to be mentioning it, but if the stiles of the doors aren't perfectly flat and straight, if they have any twist to them, that'll make the cabinet door glue up funny and hang funny. It'll never fit right. So it's essential that these pieces are dead flat after the milling process. While the wide rails will help the door glue up square, if the clamp pressure is uneven or the clamp bar is bent, it can keep the door from being flat. So I'll always double check with a straight edge while the glue is still pliable. And this door is perfectly flat on both ends. So once the glue sets, it'll stay that way forevermore. In between glue up of individual doors, I'll rinse the silicone brush in the tray of water, add glue to my dish, clean up the putty knives, sharpen them, and restage for the next door. Whether I'm doing 2 doors or 20, the process is the same. The second door I glued up had a bit of rotation on the stile on this side of the door. It wanted to tilt down ever so slightly, probably only a 32nd of an inch, and I couldn't pull it out of there by repositioning the clamp to pull up this way. So I just added a straight edge block and another clamp to pull that rail flat and true with the face of the door. There was similar rotation in this end of this stile, so I pulled it out by clamping a straight edge piece to the opposite side of the door. Doing that while the glue is still pliable will leave the face of this door nice and flat so it hangs right, and once the glue's set up in the joint, that rotation won't come back. I let the glue in these doors dry overnight, leaving the doors on these parallel rails sitting on the work surface so that they dry in a flat plane. The last thing I want at this point is to have the glue dry with the doors twisted. These extra straight edge blocks clamped on have done their job getting the doors to dry nice and flat. I'll start the sanding process with a sharp 100 grit Abranet disc to cut away scratches made by the putty knife and any other detritus that might have stuck to the surface. If close inspection shows anything left from the glue up process, I'll carefully clean that out with the wide corner of a sharp putty knife because I want these corners to be flawless when it comes time for staining. After removing the minor scraper scratches and glue residue with the 100 grit sandpaper, I switch to 120 grit Abranet and give the door frames a thorough going over. I pay a little extra attention to the corners where I started out with that 100 grit disc to make sure that all the 100 grit scratch is removed. I make a special effort to avoid sharp edges. I want those edges to be sharp and crisp till the very end. Right before staining, the last process, I'll give those just the slightest wipe with fine sandpaper to take the sharpness off but not dull them and make them look unprofessional. I do door edges separately and with different tools. I use a stiff flat sanding block and want to use a fresh piece of sandpaper to clean these up. There's going to be some glue in this end grain, so I remove that with a sharp putty knife. I want to remove any evidence of a saw cut or glue on this end grain. If I was to sand this with the Randy Morbid sander, it tends to round things off. If I don't scrape off the glue before switching to sandpaper, the sanding process drives that glue down into the wood, keeps the stain from taking. If I've used sharp, accurate tools for cutting these pieces, the sanding is minimized, but it still involves elbow grease. And this method gets that done quickly, leaving sharp, crisp edges and a flat surface behind. Did I mention that I hate sanding? Well, this is where running these stiles and rails through the thickness planer in the milling process really pays off. That amount of sanding for that kind of result is the kind of sanding that I can live with. Now that the sanding of the doors is complete, I'm going to wrap up this video because it's gotten pretty long, covering all the details involved, starting with an original door to work from and getting to the point where two identical doors of matching style are ready for hinges and stain. I'll congratulate all the viewers that have watched the whole video through to this point, and I hope what you've seen and learned has been worth your time. I'll include links over here at the end of the video, one that will show the gang cutting process that I mentioned when I was cutting the stiles and rails for these doors. And the other video goes a bit beyond the work I've done on these doors in this video, but shows how I use the world's finest sandpaper to get this satin smooth feel to the lacquer finish I'll spray on these doors. If you choose to check out those videos, I think you'll find worthwhile content there as well. Personally, I've got a bit more work to do on these doors when I make the mortises for these sauce invisible hinges that'll hold the doors onto the cabinet. If you like what you've seen in this door building process, I hope you'll hit that thumbs up button to provide a little momentum for Next Level Carpentry, and consider subscribing if you haven't already. So until the next time in the shop, thanks for watching.